So we're going to start again. I didn't have any volume there. So what we have here on the left are pictures of 2 and 5/6, and I'm making a picture right now of 1 2/3, and it's still a little off, but thirds are like a peace sign. Okay, so if I had 2/3 there, I would be having 2 of the 3 parts shaded. Okay, so basically, if I wanted to do a subtraction problem, I want to think about how I can take this and subtract out that much, right? And you guys are gotten really good at that. If I subtract a whole out, I would have to get rid of one of these. That takes care of this one. And if I subtract 2/3 out, if you look down here, 2/3 is the same as 4/6, right? So I would have to get rid of 1, 2, 3, 4 of the 6. You see that? And so in the end, now I've taken care of both parts of these, so I'm left with 1 whole and 1/6. So we would say the answer is 1 1/6. Does that make sense? Yeah. And you guys could do that. It's almost easier for you to now just do that without a picture, but when you were in grade school, the pictures really helped. But if you do it without a picture, you have to get a common denominator of 6. So you have a 6 here and a 4 there. And so you take 4/6 from 5/6, and that's where the 1/6 comes from. And you take 1 whole from 2 wholes, and that's where this comes from. Okay, so in that case, you don't need to borrow or do what we call an exchange. But in this picture on the right, it doesn't work out so nice because we could still draw the original picture 3 1/3. So if I have 3 1/3, I'm just going to line them up this way. So I have 3 wholes and 1 more third. Okay, so that would be 3 wholes, but only 1/3 of this pie, which would be about like this. So that's this number here. But the problem is, I want to take away 2 wholes and 2/3, and I don't have 2/3 here to take away. Yeah, Sasha. You could make it an improper fraction, and that would work. So what is it? What are you talking about? Which would you make an improper fraction? You could make it an improper fraction, which would give you a whole bunch of thirds. It'd give you 10 thirds, right? Sometimes it's easier, Sasha, to, well, let's look at what she's talking about. So if she makes this an improper fraction, you get 9 plus 1 and you get 10 thirds. So it's true, you could divide all of these into thirds. That's a nice way to do this. Not a perfect picture here. But now I have 10 thirds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 thirds. And so I could take away 2 2/3 because I can take away 2 wholes. So I could get rid of this one, 1 whole, 2 wholes, and then I could take away 2/3. I could get rid of this third here, and I could get rid of 1 of these. So what am I left with? Just no holes, right? I'm just left with this shaded part, 2/3. So one way is to do an improper fraction. I will tell you when the numbers get big, that becomes a lot more work than doing something called borrowing. But that makes the most sense at first. So let's take this picture and show you how you can do some borrowing. Okay, so I want you to think about this one more time. if you take 3 wholes, again, and you're 1/3, so this takes a little bit of time to explain. So here's your 3 wholes and 1/3. Instead of doing improper fractions, because if you look up here, we crossed out 2 wholes, didn't we? So you never really needed to turn those to thirds. So Sasha, think about this. What if I just took one of these and divided it into thirds? I'm going to add a page in here and look at both pages at the same time. So I've taken my problem 3 and 1/3, and I'm changing it to 2 wholes. And how many thirds do I have? 4 thirds. Okay, so watch. This is the same thing as 2 wholes and 4 thirds. Do you see that? Okay, because I'm taking this whole and I'm dividing it into 3 parts. So now I say I only have 2 wholes, and then my third whole I'm going to call 3 thirds. And I'm going to add another third. So when we borrow, what we do is we say, well, we're going to take this 3 and make it a 2, but we're going to add a whole here. Here's the third part. So this 3 and 1/3 is the same as 2 and 4 thirds. That's the same. This is the same thing as 3 and 1/3. Does that make sense? Because now, when I want to subtract 2 and 2/3, I can take 2 from 4. But before, over here, I couldn't subtract 2/3 from 1/3. So borrowing allows us to rewrite the fraction as an improper fraction. And then when you subtract, you're going to take 2/3 from 4 thirds, and what do you get? 2 thirds. And then 2 take away 2, you get 0, so you just get 2 thirds, and we could do that without a picture. Okay, so we're going to practice that today. Okay, let's set up to do a couple of notes. We're going to practice subtraction with borrowing. And what's your question, Kanan? That wouldn't require borrowing.
Yeah, I know. But it's harder to walk.
Okay, so practice.
But
I'm not sure I understand your question. Say it again.
so like,
I'm going to pause this. Do the first one and I'll record it. So we're going to do borrowing again here. And let's make this a little bit. Wow. What happened there? I don't want that. Okay. So let's have somebody new. So Claire, what's the problem with this if it's a subtraction? What do you see that is not really possible? You see a problem here? If I want to subtract 2 thirds from 1/3. Because 2 thirds is bigger than 1/3. Can't do that, right? So Jackson, I'm going to change this to be 6. Okay, so how much do I have to add here? 3 what? 3 thirds. So this is a whole right here, 3 thirds, right? So 6 plus 3 thirds, that's still 7. Okay, so if you guys write in your notes, if you do this vertically, sometimes it helps beginners working across the page like this. So every column you rewrite it to be a little bit different. And so I'm going to rewrite this over here as 6, but now I'm going to write it as 4 thirds. And then I'm going to look and see if I can do my subtraction problem. And if I can, then I don't need to use another column. Okay? So Mark, can I do the subtraction problem now?
yeah.
What do I do? So 4 thirds take away 2 thirds is 2 thirds. Right. And then 6 take away 4 is 2. And then that's your final answer because it's simplified. All right? Raise your hand if you have a question. Let's start with questions. Yeah, Michaela.
So for like taking away wherever you took away 4/3 minus 2/3,
Mm-hmm.
and it just stayed the same.
That was a coincidence.
Yeah, because 4 minus.
Right, because 2/3 is exactly half of 4/3. But I bet if I give you another problem, they're not always going to be exactly the same.
Okay.
Okay. So let's make another one up. I might have already made one up. Let's see. Uh-oh, gotta hide this one. So let me clear this. Okay, let's try this one. So there's two problems here. What's the first thing that you notice? Yeah, Kanan? Yeah, before you decide if you have to borrow, you have to get common denominator. So Quinn, what's the common denominator going to be here using 3 and 5? 15. Good. Okay, so Andrew, if I want a 15, what do I have to multiply the numerator and the denominator by? I'm still going to have a 1.
Times 5.
Yeah, so times 5. Good. So what do you end up with in the denominator, and what do you end up with in the numerator?
10.
Perfect. Okay. And so up here, Claire,
Yeah.
what do I have to multiply by to get 15 in the denominator?
5 times 3.
Times 3, right? So I have to do the numerator and the denominator by times 3. So I still have a 4. The 4 is still going to be there, but what's in the numerator?
9.
9 fifteenths. So 4 and 9 fifteenths. And then I'm going to take away 1 and 10 fifteenths. So, Kyle, can I do that without borrowing, or do I need to do a borrow? How come? You can't subtract 10 fifteenths from 9 fifteenths. Okay. So let's see, Nick, what do I do when I borrow? What do I have to change?
You have to change the 4.
Right, and I'm going to change it to 3. What do I add here?
You add 15.
Perfect. You're adding a whole, and it looks like 15 fifteenths because we want it to have the same denominator. So I really am going to write this as 3 and how many fifteenths?
29.
24.
24.
And take away 1 and 10 fifteenths. So Andy, can I do subtraction now without borrowing? So what do I get on this last column?
For 2 and 14.
14 fifteenths when we subtract the fractions, right? And then 3 take away 1 is 2.
So much more sense now. That's so much easier.
Do you see that?
Yeah.
It's better than, I mean, the picture's better because it makes sense to you, but the pictures get really complicated.
Yeah.
You always want to start with the picture at your age. I think it helps. But then if you can understand how to do the rules, that's really nice too.
That's so much.
So you want to try a practice problem?
Yeah.
Okay, Sasha, I'm going to write a practice problem up. Sammy.
How you got 23 and 24 15? Like, how did you get the 24?
Because 9 plus 15 makes 24. Okay. So let's do a practice problem. Okay. So we'll have to start it, Clem. What's your denominators?
12.
12, right? So multiply the numerator and the denominator by 3 to get that, right? So you get 9 twelfths. What'd you multiply the numerator and the denominator here by? 2. So you get 10 twelfths. Okay, so let's go 6 and 3/4 are 6 and 9 twelfths. And take away 4 and 10 twelfths. And it really helps, I think, to do the vertical because then you remember to subtract the bottom from the top. And what's the problem here? You can't take away 10 from 9 So we're gonna borrow. So did you have a question or did you want to keep going?
Yeah, I had a question.
Okay.
Like, so then you add 9 is 10?
No, then you change 6 to be 5.
Yeah.
And then you add,
I did 4, or I changed the 4 to a 3.
no, because that's why, did you write it vertical? So if you write it vertical, the left one's on the top, and you're only going to change the top when you borrow, because you're taking away from the top. So I'm going to change the 6 to a 5, and then I'm going to add a fraction. What's that fraction going to be, Michaela?
12.
12 twelfths, because that's a whole, right, Quinn?
Yeah.
So 12 twelfths plus 5 make that 6. So over here, I'm going to rewrite this as 5, and then I'm still going to have twelfths, but I have 9 plus 12. When we add this, 21 twelfths, right? And then I'm going to subtract 4 and 10 twelfths. So, Michaela, what do you get?
You get 1 and 11 12.
You get 1 and 11 twelfths. So this is what I want to do tonight, you guys. I made that homework assignment. I'm going to shorten it up a little bit and have you practice maybe 5 or 6 of them tonight. Make sure you could do those before we do a whole bunch. Okay? So I'm going to stop this and record it, and then I'll change the homework.